Here's some code in the sample project that implements the sale class. The class contains an amount property and code to perform a comparison. As you can see, it implements the iComparable interface. So again, this isn't something that's defined within the sample project. This is part of the .NET framework, and its fully qualified name is system.iComparable. And so right here you can see that the .NET framework uses that convention of using names of interfaces that start with an I. Okay, because I'm saying that it implements this interface, I have to implement a single method. So this takes care of implementing that interface. Now the iComparable interface defines what that method has to look like. It's going to return an integer, and it needs to take an object as its parameter. So it first checks to make sure that the object that is being passed in is the sale object. Because this compare_to method is being declared within the sale class, I'm looking at comparing instances of the sale object. Okay? So it needs to be a sale object. If it isn't, then I'm going to throw an exception because I'm using this method incorrectly. Okay, then if it is the right type, it's going to cast that object as a sale, which then assigns a reference to it to the temp variable, which then has all of the properties and methods of the sale object available to it. And then it uses the amount backing field, calling the compare_to method on it, and compares the amounts. So this is kind of interesting. This is not recursion because this is not calling back into the same method. But what it's doing is it's using the compare_to method of the amount object, in this case the backing field, which is an int, and comparing the amounts that way. Okay, now I can implement this compare_to however I want, as long as the method returns the correct return value. Okay, and I'll talk about that in just a moment. But this is really kind of weird here, because the amount property of the sale is an int, which itself implements the iComparable interface. So the amount property and the amount backing field have a compare_to method as well. All right, so how can we find this out and verify it? Well, I have open in Internet Explorer the int32 structure, which is the structure that is behind ints in C#. And here is the syntax for it, and as you can see, it implements iComparable, which means that int32, just like pretty much all of the other built-in data types, implement iComparable. So I can use that. And then I can go over here to the iComparable interface to get more information about implementing it. So I can see that I only need to implement a single method, very common within the .NET framework, just a single method, but oftentimes there's properties and other methods as well. And then the way it works is in this table right here. So this determines the return value of the compare_to method. If it returns less than 0, then the current instance precedes the object specified by the compared_to. So that may mean it's less than, it may mean that it's alphabetically before it, or some other ordering that makes sense for that particular object. If it's 0, then the current instance occurs in the same position in the sort order as the object that's specified by the compare_to method. So the two things are, we would refer to them as equal, but that may not make sense in some context to call it that. And then greater than 0, an integer greater than 0, the current instance follows the object specified by the compare_to method in the sort order. Okay, so less than 0, 0, and greater than 0. Okay, so now I can compare two sales objects. And this kind of makes sense because how this works, because I'm comparing amounts, numeric amounts. It's well understood the order in which numeric amounts occur, but it's nice to be able to now compare the objects. Okay, so here's some code that takes a look at that and does a comparison. Instantiates two sale objects, and then sets the amount to the first one to $5,000 and the one to the second one to $750. And then the code compares the sale amounts three different ways. Okay, so the first way here is sale amount 1 dot amount greater than sale 2 dot amount. So this is a regular comparison of two integer values, and it just uses the greater than comparison operator. So it's going to return true if sale 1's amount is greater than sales 2, which it is. 5,000 is greater than 750. Then the second way it compares them is by calling the compare to method on the amount property. So this option right here is going to use the ints compare to method, strictly speaking the system.int32 structure, that implementation of compare to, in order to compare the value of each sale object's amount properties. So this is again a comparison of integer values, but uses the compare to implemented in that int32 structure. If the return value from the method is greater than 0, then sale 1's amount is greater than sale 2's. And it still is. So this is going to return true, and it's going to display that message. All right, and so this is really the interesting one, where I'm comparing an object in memory to another instance of that same kind of class. So I want to find out if sale 1, how it compares to sale 2. If it's greater than 0, if the return value is greater than 0, remember it can be any number, it's not necessarily 1, then it's going to display sale 1 is higher than sale 2, which once again, it better be. But the important thing here is that this is using two objects. So it's using sale, an object of type sale, and the object itself, really the class, the sale class, can determine how that comparison is done. It happens to be implemented same way essentially as what this is doing. In fact, that's really essentially the code in the compare to method, because it's comparing that. It's using the backing field instead of the property, but it's essentially the same thing. And it's now returning an integer value. Okay, I'll go ahead and run this code. And I'll select G. As you can see, sale 1 is higher than sale 2 in all three cases. That's a relief. And that shows how you can compare different objects.